Welcome back to my garage. I postponed to record an intro. This is the intro. So first of all, thank you to all my new patrons and the other patrons and to all the people who has been donating. Thank you. Really means a lot. So we're working on making a flow bench of sorts for testing, so we can figure out if there's enough support for enough airflow through the whole brute force concept engine. This version of it. We have other versions. See if it's doable. If we can, with the Rotrex blower, get enough flow through here and create more pressure than create pressure for more power than what you can achieve in a normal two-stroke. We're gonna hook up this kind of apparatus with a mass airflow sensor and also a pressure gauge, and I'll show you later. On with the show. I was gonna weld this to this, thinking this was steel, but it's cast iron. I don't want to risk the brittleness of cast iron welded to steel on this. You know, don't want to have this flying in my face. Which is a bummer, because this has a taper lock bushing, and if I had welded this to this, you know, taper lock. Plan B, turn a registering flange into this and then screw the bolt, the other pulley, other sprocket to this. This hasn't got the taper lock bore, but it has this 20mm bore, which of course is the axle I'm going to use this for, which I'm going to show in a second, is 19, but I have a 0.5mm sleeve I've made, so set screws are probably good enough. It's not running super true, but it doesn't matter, because it should be true to the mandrel I just made, and the registering flange will be true. I'll bring you back when I'm done. This will take forever because I can't speed down the lathe. I'm gonna press this together and then drill out the holes. It's just the paint holding it, not having it go on now. It's already loose on there. So this is not gonna work. But let's see if this starts though. is the most accurate way I can measure this, because I haven't got the micrometer large enough to set a bore gauge, and my 3-point micrometer is also too small. But it seems to be pretty spot on. Probably not super round, but I think round enough for a press fit and some retaining compound. A larger 3-point micrometer and a larger normal micrometer is in a couple of weeks will be in my hands. The point here is to press this in. That was stupid. It's slightly smaller down at the bottom, and now it's stuck in there. I need to order a 19mm taper lock bushing, but I'll use my my little sleeve in the meanwhile temporary solution. And you know how it goes with temporary solutions. It'll probably be fine though. I'll fiddle with this until we're set. I'm within 0.02 millimeters now. Should be good enough. As is tradition, I don't think I pressed record. I just mounted this on here. I think those rubber mounts might be a problem, even though it would remove lots of vibration from this, but automatic chain derailleur 3000. Yeah, well, that's not gonna work. I'll have to just hard mount it to probably not this piece of wood, but do I dare starting it up and see how it behaves? If I stay on this side just to see how bad this is. I do dare. Do we dare try it with the blower connected before we end before we call it a day for today? I think we do. So that'll work, but the rubber mounts definitely have to go. Or at least we'll have to replace them with something more substantial like these. That existing beginning of a cut is actually in a perfect spot here. Ah, fuck. And I was wondering if I should deburr these edges earlier. Well, a little bit too late now. Funny how these holes ended up exactly like maybe a couple of millimeters off in the middle, which was not my intention. I marked and drilled for where the engine was positioned. Probably too slack, but we'll see. Might need to add a tensioner. We're gonna start the engine and run it a little bit without anything connected first, just to make sure it's up to temperature and running. And then we'll attempt starting it under load, and hopefully it works. I have a feeling this will be replaced by a large electric motor. I just need to hook up the 3-phase in the garage. It's the wires are there. Okay, let's hook up the chain and see if we can start it with everything connected. Otherwise, we'll clutch or electric motor. Bad idea, I think. Powerful electric motor, I think. I could slip this, but it seems just like a stupid thing to do. This is not a slippable belt. I replaced the gas in the engine. That could have been why it was running so badly, because now it actually will run with the large sprocket, but it won't rev properly. It runs with the smaller sprocket, but then the maximum RPM I can achieve is about 7,800 RPM at the blower, which corresponds to about 100,000 RPM impeller speed, which in turns means about 4.5–5 psi maximum pressure and an airflow of about 144 kilograms an hour, which might be sufficient for testing. I'm gonna take off that big sprocket again, and also the taper lock has shifted on the axle and crushed my shim. So I'm not, like, it's weird really, because there's usually the taper lock, well, a taper lock with a shim is probably not good enough. What I'm gonna do is, the taper lock bushing takes a 6mm key. The axle takes, well, the best thing would be to get a 19mm taper lock bushing. I'm gonna order that, but until then, I'm gonna grind. And the axle is 19mm and wants a 5mm or so key. So what I'm going to do is I'm going to grind a little bit off the 6mm key so that it fits in the 5mm slot and also in the and isn't loose in the taper lock bushing. Point now, hook this tube up with the MAF sensor here, and at the other end I've got this contraption, which has the pressure gauge and has this gate valve, which is the gate valve I printed for my air supply to the metal melting furnace. With the speeds we're achieving, we should be able to produce about 4.5 psi. So whatever pressure we're seeing at the gauge here, 4.5 will be the maximum we can try to achieve, otherwise we'll be in surge. What we're going to do is set it at a suitable pressure and then look at the pressure, the compressor map, and compare with the readings we're seeing from the MAF sensor. And in that way we can confirm if the map we have found for this MAF sensor is correct, or if there's other maps that corresponds better, and find the right numbers. And when we have those right numbers, then we can start testing and hook this up to the engine and see what kind of airflow we can see at various pressures. Of course, now with that stupid 4-stroke engine, we can't run more than like 4.55 psi, which is not a lot at all. But we could actually start testing some compounding, and but then I'll need to get an intercooler and see if we can double that pressure as long as there's enough airflow. I really wish there was a place in town where they had those taper lock bushings in stock, and I didn't have to order. I hate waiting for stuff. It's a little bit wrecked. Really soft. This axle is really soft. Before hooking up the valves and electronics and stuff, let's see if that engine wants to run today, or even start, and take it from there. Then hook up the MAF sensor and this stuff, and see if we can get some baseline readings, and then onto this. So now let's hook this stuff up and run it again, and it might just fly apart because no clamps here, so we'll have to put on some clamps if that is the case. But and see if we can adjust this and get it up to about 4.5 psi. Okay, the valve is fully open, but this is creating a restriction. So let's see how much pressure we're building with just this restriction. And let's see if it even starts now because of the restriction. About 3 psi. And I need to clamp everything properly. This is good. Now we can start restricting the outlet until we see 4.5. Let's hook up the electronics, clamps electronics, and then with a known pressure and a known value from this, we can find the correct map. I'm going to put a fan on the oil cooler. I've hooked up the MAF sensor and I'm reading 1 volt from it when there's no airflow, which is the correct voltage. So what I want to see now is if this Bosch mass airflow meter graph is correct. And with the Rotarex blower spinning at roughly 100,000 RPM, we should see 0.045 or so kilograms per second at 3.3 bars, and that's like 4.5 psi. So I'm going to set this as close as possible to 4.5 psi, and then we're going to see if, so 0.045, that corresponds to about 165 kilograms per hour, and according to this, that should be roughly 3.3, between 3.2 and 3.3 volts. So if we're seeing that, then this is probably the right graph for this sensor. Missing hose clamp came back to bite me, but we got the number we were looking for. We saw like 3.25, something like that. So, which means our numbers are correct. Which means we can actually remove this and hook the brute force engine up like it's sitting now and see what we can see. As a final test for today, the bench is actually working, I think. We replaced the restriction valve with the whole brute force concept engine. Currently sitting at bottom dead center and with all the exhaust valves fully open. Now we'll get a little pointer to if there's enough airflow through here, and there's room for lots of optimization. First of all, this inlet hole wasn't really meant for an inlet hole and is really small. The one on the bottom is much larger. And also there's a T section back here, which could be a Y for better flow. And if we can't get enough flow through the crankcase, I'm using the crankcase for lubrication purposes. There's no crankcase pumping here. There's no transfer ports connected to the transfers really. But for lubrication purposes, that's one of the points. The other point is that this is a two-stroke. There's ports in the bore, which means the piston ring is only really sealing it's never sealing the ports from the case. Would be like if in a four-stroke you had like the valves, there was always a gap of communication between your intake and exhaust valve and the crankcase, which means it's not as straightforward as you would think to create a four-stroke bottom end for a two-stroke, because there's no seal there. Like you could create a special long piston and some oil rings and stuff under the ports, but lots of extra friction. So just lubrication through the... I'm rambling. What I was saying is, what I meant to say is, I can also have a plenum external to the case, but have like a path through the case also to take care of the lubrication, but have main flow going outside of it if this doesn't flow good enough, which it probably won't. But stuff will probably fly apart, connections and stuff, because there are no these aren't really, there's just a friction, there's no lip, retaining lip or anything. And let's just see, as end to this video, actually kind of a successful end to this video, where our goal, the goal of being able to test the flow through this engine, will now probably be achieved. Yes! I suddenly didn't feel any more airflow. That's why I stopped it. But it might be that it just, I think one of these valves spun and closed You can probably see it in the footage. I'm a little scared now that I destroyed the blower somehow. I was getting really nervous that somehow the blower had been destroyed. Would have been weird though, because there's no reason for it to be, but I'm wondering if the piston got pushed up to top dead center. Yes, yes it is. Yes it is. Yes it did. Okay, so we got to keep the crank from rotating also. That's now the piston should stay at bottom dead center. I feel like I'm talking like a robot today. At the bottom, there's a guy at working in our local grocery store, and I think he has some issues. But like for many months he didn't really speak at all. But now he's learned like the syntax of our language, and he says "ha det bra," which is like a robotic goodbye. Which is that's pretty much the only thing he says too. It's kind of funny. So with how everything is set up right now, we produced about 3.5 psi, and the airflow meter, I have to watch the video, but I think we were sitting at like, I'm gonna make a better gauge with averaging because it's impossible to follow the serial monitor, but we saw like 3.3 or something volts, and that corresponds to, well, a slight bit above 150 kilograms an hour. So say 160. At bottom dead center, with all the ports open, and in this current configuration, it supports, we could like run 100 cc. It flows 100 cc at 15,000 RPM. It would flow 100 cc if it was staying at bottom dead center all the time, which it, of course it doesn't. But we know that now that at this position it flows at 0.25 bars, which isn't really a lot, but at 0.25 bars it flows this much, like airflow, that kind of airflow, and that's too low. Like if we were to run this low of a pressure, we won't produce any power. So we need to amp up the pressure, and when we amp up the pressure, we won't be able to support the airflow the blower will produce, and will end up in surge, and that's why we'll need to have like a divergent valve. And the idea I talked about before, which how we can diverge flow from the intake part, from after the compressor, into the inlet of the compressor, and have a reed valve to atmosphere, so that it's possible to build higher pressure in the inlet and compound. We can compound it. Compound blower with just one blower. Compound blower setup with just one blower. I've talked about this before. The problem will be heat, so we'll need a couple of intercoolers. It's a good thing I've kind of settled on doing land speed racing, if any racing at all, because if we can make this produce lots of power, we'll need a special kind of bike to support all the intercoolers and piping and everything. But it's looking promising. It is, because this is so unrefined now, and seems like it'll flow, and it'll flow much more at higher pressure, and we can, like, at 10 times the pressure. That's my, like, at least 10 times the pressure, 2 bars. We can, so we'll have to get there somehow. And we can't compound 0.2 bars 10 times. There's not enough airflow for that. We need to spin the blower faster.
diverged flow and all that. But a good start. The test bench is actually working. We can get some numbers now. We can start testing various positions and actually get a feel for how much RPM we can support and still have sufficient airflow to say have a 200% cylinder filling, like 100 cc into 50 cc, and see what kind of RPM we can support with that kind of cylinder filling. And then start working on optimizing things. But I think this will flow enough to not have to run the reed valve ahead and stuff. We're getting somewhere. Next time.